because because in the first submatrix we have 1 comes to this, when it comes to next row it's darling.
It's 1.
So that means that at the initial row of another submatrix, or that row of the second part of matrix, you only have 1 1.
I understand.
So that means that okay, that's the greatest zeroth when you have is whatever is answered 1.
For 1, yes.
Okay, so the rest is whatever it is, even is less than this.
It is.
It is less than this,
Yes.
but you need to know the link between this and the initial part of the matrix to see either they are greater or not.
Yeah, if we consider this whole as 1 compared to this one, right? But now I see now we have got like say.
Don't worry about this, what
these
I wrote
ones.
in there. Don't worry.
Oh, okay, all right. So this was I was saying, okay, Sina made this submatrix.
That's because even you can make it as submatrices. You can make it different submatrices. You can. But
And then, but the best I think would, that's where I got confused, because what I wanted was to link this to that and say this one does not link to this one, therefore our optimum best error correction is what we get here, which is the L for this one.
no, because no, you can say that you delete number of rows.
You don't consider the number of rows
And
after
then,
this
that's
one.
right. And then you can see how much you will have the rest, and see what would be your case.
That would be the optimum.
Yeah.
Optimum.
Don't worry about this row. You know what we did for the new algorithm? We tried to remove number of rows in the submatrix 1. Yes?
Yes.
So that one, okay, automatically gone. No need to calculate about C0 plus C2
No need,
plus, no
yes.
need, because this one is there.
Yes.
So automatically gone.
So now what's remaining is
The remainder.
the remainder one.
Yes.
So that's now we consider it.
That's right.
And we're saying out of that we have our optimum. Because right
We
here,
don't know about optimal. We have to prove that this is optimal.
optimum.
That's why we discussed yesterday.
Because yesterday and today we are now discussing expression of codes with optimum
That's
based
right.
error correction.
Yes.
It is okay from this one.
Yeah, don't worry about that, because it's one is there. Always you will get 1. Okay? It's surrounded by 1. Zero span is 15. Okay?
Okay, that's cool.
Then you can see, because it's surrounded by 1, and that 15 is less than delta minus L, lowest delta minus L. Lowest minus delta minus L means greatest L. Greatest L would be 15.
15.
31 minus 15 is 16.
16.
This 15 is less than 16. That means don't worry about
This one. Okay, we
Then the
consider
rest.
16.
But this, if it is 15 plus this means the remainder is 14. 14 is also less than 16. But when it's combined with the top part, would be maybe greater.
Okay.
So, but we have to see about the link between the last part of the second part of matrix and the initial part, and see, can we find a pattern which creates for you and generates a continuous zeros.
Okay, that's why we've got this one here as
Yeah.
the initial.
That's right.
Is the 2 rows from the initial to make it 16.
To see
To-
either we
to
can or
see
not.
whether
Yeah.
we can. Yes.
Yes.
Yeah, that will make it 16.
Yeah.
Okay. All right. Okay. I was confused. I was trying to draft in this.
Yeah. So, but we need to know about how we can prove it, and we have a big problem in there.
Because I was looking also at these ones you circled, and I was thinking they have a meaning.
The case for me is, if you want to see, I don't know. I was thinking right now about that. I have to have time. Maybe the case which I said is not really clear to you to say how we do it. What I tried to do to say that this is the last row. This is the last row of the matrix. Okay.
Yes.
That one this one is C0 there, right?
Yes.
The first row also you have C0.
Yes.
So, but in other columns you don't have any common one, because the only common one you have is C0. The rest you don't have. So it means that whenever you get zeros there, okay, whenever you have position of those columns as 1, okay, for example, if you have if you have like C0 plus C whatever, like C4 plus C10, this is the last row, this is the 0th row of matrix. Matrix, okay? So the C0 plus, still you have that one, right?
Yeah.
If this is 1, this is 1, and you know that there is no common 1 between these two rows. So it means that if it is 1, that is 0. If it is 0, this is 1. So if it is 0, this is 1, right? If it is 1, is 0, right? So it means that if you can find a combination saying that we can't find any combination saying that there is a common 1
in this one,
okay? So, or you can say that there is nothing. You have to say how we can. That means when it's 1, the rest would be either 0. If it is 0, this is 1. If it is 1, the sum of that should be 0. So if you can prove this one, that's job done. Because always you have C0 there. You always have C0 there.
Because then that will mean that we are going to end up with the 1, and then it means we stop.
Yes. If it is 0, is 1. If it is 1, is 0.
Yeah, so the two of them, we're going to end up
means
with
that
1.
Okay, in order to continue, to make a link between the last row with the initial one, then we can say you should have 0 there.
Yes.
So what possibility you have as 0 there? Is there C0 plus C1, C2, right? C0 by C2, we can make it. Or we can do C0 plus 0, 1, 2, 3, 4, 5, 6. Okay? And the 6, 7, 8, 9, 10, 11, 12, 12, 13, 14. Yep.
Okay.
So this is the 0th you take. So, but when you go to this is the last row. The 0th row. What possibility you have? You have C0 plus C1, C0 plus C3, C0 plus 3, 4, 5, 6, 7. Okay? And then C0 plus 15. Okay?
Okay.
So if you say that, that means if you do C2, C6, C14 combined with this, with one of them, or yes, it's possible to get that one. It's 0, that's 0. But what's happened next row after? C0 is now 0 because you have C1 there. You have there, because it is the first row. C0 plus C1, this is now 0. C1, because before you had 0, C0, 0, that shifted to 1. And that because this is 1, C0, C1, C2 is possible to have 1. And that means something happened. But now here is C2 is 0. Yeah, that's what I say. This is C1, this is 0. But this one is... yeah, that's stop there. Because this is 0, 0, 0. Yeah. Okay, I understand what it means.
Mm.
I understand what it is. What we did there,
Mm.
what we do there, because if you want to have continuous one,
Mm-hmm.
you have to go for higher rows too, before rows.
Okay.
So
Mm.
if you have the C0 there,
Mm.
right? If you want to make patterns with longer length,
Mm-hmm.
so you start from this point, right?
Mm-hmm.
You start go 0 0 all.
Yeah.
That C0 definitely should be with C5.
Yes.
Definitely you should
Mhm.
have this one as C8.
Yes.
Then C8.
Okay.
That C8 now is 1.
Okay.
It's 3 1.
Ah, okay. Yes.
Stop.
Yeah.
Definitely you need to have C8.
C8.
If you want to bring something from rows, the maximum rows,
Bring down.
down. Yes.
Okay.
Otherwise, wherever you are there, you have
Mhm.
to continue for the rest.
Yeah, okay.
And you will see about maybe same thing
Mm.
to see that it rejects.
Okay.
So for example, if you do from this row, because you did from this row, we did this, we ignore this one. This is C0 with this one, right?
Mm.
If you say from, we consider C1 there,
Mm.
C1 with what you do have? Nothing.
Yes.
C0 plus C1, nothing. That means it
It's
starts
one.
from there. Again,
Mm.
the same as the concept we have there.
Yes.
So then it is C0 plus C1, therefore you come to this one, C0 plus C1, you see,
Mm.
with what? You should do with, again with this one,
Mm.
you know, definitely is, there should be this. So that's fine, when you come to this, you have to come this. When you go down, after this, another row is again become 1.
Yeah.
Then stop. But how we do that, I don't know. I mean, maybe we can do it by more investigation. Definitely is best, the optimum. But I don't know how we can show it. How we can show it, I don't know.
Think about it. Along the lines you've explained to me, I think I'll consider and I'll write a draft.
No, but how we can make a link between the last and the first one?
The first two.
Yes.
Because that's the link we need so that we can say the optimum is 16.
Yeah, but I mean, wherever you are, it's not important because you have still 15 rows.
The
You know,
15, yeah.
the 0, this is maximum. You can say 15,
15, yes.
and then 1, this is something, and then you can say 1, couple of zeros there, right?
Uh-huh.
So that is maximum is 14, and that is 15, 29, still is 16. So if you start from there as 15, if you ended there, the last row you have 1, okay, that's fine. 15 is still less than 16.
16, yes.
That's it, okay?
Mm-hmm.
So that means whenever you get 1 there, you should get this one 0.
0.
Okay, that's fine. But if you have 0 there, if you continue there, how many you can go down? Maybe if you say 15 there, this one, if you say, if you start from there, if it is 0, you can say 1 0 there, but 15 0 is still is 16. And then
16.
you can. So that means that whenever you get 0, you should not go for 15 more rows to get 0. You have to reject it for any rows you have there, and that makes difficulty, and that means you need to consider again possibly sum of whole columns. And that's why, because this is like I said, it's a new thing we have, is maybe we don't have any choice to do that unless we do sum of whole columns. But that one,
Sum of all columns, that's what I was thinking. That's what I was thinking. We can easily.
no. If you start with the first row, say that if you want to see the maximum, if you say about the maximum zeros you can take is 14.
14.
And you want to see how many you can go more.
After
You can't go with more than 1 because if you start from there, because you start from there, right? So that definitely you have to have C0 and C8. For sure you have to have. Any combination you do, C0 and C8, that would be 1. Okay? When that's possibly we can do that because this is 1, this is 0, right?
Then it's
No, because this is matched with this one, right? So there is no common column between them because this is 1, and you know that this becomes 1. What you can get conclusion there to say that if this is combined with 2 of them, because it's 0, 2 of them is say about 0, 3 of them 0. You have to consider whole again. you can't fight with that. But the algorithm we have, you can apply in here to show that, okay, that's fine. But we want to get rid of the algorithm we have there. You can apply that algorithm, which you know now. You can apply it to show that it works. And it works. But we want to show something maybe simpler.
Yeah, that one we're gonna apply. Yeah, this one will be like, if we can show this one, then it's a shorter method of determining the maximum, optimum maximum solution.
When we say, hang on. When we say, for example, this one gone, how many rows it remains? 14, right?
It's 14, yes.
14. About 14
rows.
Plus what column we have, we don't know. What column we have to say that this is less than
the column we have
delta. No, hang on, just a moment. 31, 36, 31 minus column number minus 1. So it means that 2 column minus 1 should be less than 17. Column should be greater than this 2, 19 over 2. That means column should be like less than or equal to 9. Yeah?
Yes.
So below should be greater than or equal to 9. Okay, because when you remove this, okay, so you will come to this one to say that, okay, so below should be greater than 9. It's after this. So it means that you should come to this to check. This check. You see, after 9, how many ones we have? Only 1. After this is C because this is column number is 9. Means that 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that from this beyond. So only you have 1. You know what I'm saying? So it means that wherever you have exactly the same, you know, this is like wow, exactly the same as what we found there. So that doesn't. So it's a C0, C8, C0, C8 plus this, like that. You can ignore this part too, but I mean the rows is just this to see either you will have zeros at the end or not. Because you can add these number of sum depending on what row you do. It's the same as the algorithm you have. Then you can say see it again. You have to combine whole and then calculate about the whole possibilities you have for the second part. You know, but for how many rows you have there? 1, 2, 3, 4, 5, 6, 7. The 7 rows. The 7 rows you have to consider the whole possibility, right? C0 and till that one. C7. There should be many. The last row is C6, yeah, C0 to C6. And then all combination with that one.
Okay.
But that's next. Unless we do based on what we think in there. I don't know at the moment. I have to think very carefully. I don't know if I can do it by proper setting for you before you go. I don't know. But try to write as best as you can. But you can write still. You can say that. Don't need to prove it. Just to say that if you do this, to say that it proves. It proves. It proves. I mean, it's not the case to say that it rejects. No, definitely it proves. It is a right thing, but possibly the proof we have is not very strong. That you can do based on our own algorithm, which you do the C0, the same as what you did for the other. You can say, but you need to do it based on that number of rows. That means that but for any code based on that structure I discussed with you. You know, then you can say about how many rows you delete and how many rows you have to consider. So the structure of the code is this. It says about hx is given by like that.
X squared.
You can say based on what you say in there. That's fine. It says about if you have this, for example, how many rows you delete. How many rows if you get this? How many rows you get this? How many rows you get that? You can find the formula to see. Yes, because half of that is there. Isn't it? How many zeros you have? The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. This is 8, right? 1, so 7. 1, 2, 3, 4, 5, 6, 7.
Yes.
So 7 plus 15. So means that whenever you have there, even you have 31, if you are in that order, this plus this.
15.
Plus how many rows? You have 1 row you deleted, this row you deleted, means 2 more. Means 15 plus 7 plus 2 is 9, 24. 31 minus 24 is 7 bits. 7 rows remain. You know? Then you can consider that you can do the same algorithm you know now for the last 7 rows.
Okay.
And to see, so you can write in that way. Unless if you can find something simpler, you can add at the end. Otherwise, it works.
I think this is. I write it this way. I base it on because it's expression. So I base it on that one as the expression for the parity check matrix.
You get what I'm saying?
Yeah.
Just map it with what you know. That works. But what was my aim to find something much simpler? You know, to say that okay, but seems no, no, doesn't. That makes difficulty.
I'll write it in this way for that one.
Yeah, that's okay.
15, 7 Because we have.
Based on the order you have for HX, the last, except the highest one, the last, the last two highest ones.
Okay. Alright. Oh, that's fine.
Do you get what?
Yeah.
It's easy to understand, but I mean, in terms of how we can find this.
Easy to understand, but to express. But I think using that one, this one here, it's using this one is better.
No, the find to say that BHN definitely is optimal. Not without any sum calculation. And I tried to find that one for you, but it seems no.
All right.
If I found it, I will let you know. But we still have time for 2 weeks, 3 weeks time. I mean, you know not about how it works.
Yeah, I know.
We still really in touch with each other. If I found,
Skype,
yeah.
Yeah, Skype. Then the last bit. I need some. Last time you gave me some hints
Or what?
on the codes, finding the codes using MATLAB. Yeah, like what codes I can investigate to get in MATLAB.
You did it.
The same?
Yeah, you found code, right?
Yeah, I did.
But the thing you need to do, because possibly you did a zero spans, you'd consider more NZ1, NZ2, NZ3, NZ4. You don't need to consider NZ2, NZ3, NZ4. Just consider that you have distance between the two greatest orders.
Okay.
Because you only consider the first submatrix. It doesn't matter what rest you have. You know?
Okay.
Just you need to consider the first one. Therefore, there is you should have a distance between two greatest orders. Should not come immediate after each other.
Okay.
So now, for example, if you have, for example, 7, should not be 8. Maybe 9, maybe 10, maybe 11. That means you add zeros, you make a zeros between the. Okay, it means that you make a pattern. What do you do?
Because the camera can see this one.
Okay, the pattern, for example, with length, with L, whatever. For example, whatever, with L. Example, L 10. Okay? Make all patterns. Right? Whatever. 10. Okay? So then you can say add number of zeros to the end of each pattern, followed by 1. Okay, because again, all patterns with L started, you can say, by 1. Because HX 1 plus at the end you have to have order, you know. This is HX structure. 1 plus X K, right? That means order should be 1, 2. This is 1. So 1, blah 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 blah, then 1. These 2 ones. This is this. This is this.
Okay.
Okay.
So I can use this one.
Yeah. This is an example, no. Just search by yourself to find code.
Find the codes.
Okay? Because then you have this, it's a 1 plus, for example, X, I don't know, for example, 2, for example, 4, for example, 7, plus whatever, for example, 10, right? Then, this distance, because you added 0, you can say, for example, I don't know, we can say 15. That means you added how many 0? 4 zeros. So NZ or Z1 is 4.
Okay.
Then you have this. Okay, but for this one, find the first n satisfying xn plus 1 over whatever your SH is. Okay? So that means the remainder is 0. I get 0. Okay? So if it is, take n. The first n. Take n. Okay? So cyclic code you have n, add number, okay, L plus NO0. So for example, you added 4 zeros there, right? What was the length of that for 10? 10. The length you have there is actually 11 in here. L is 11 because it's not from 1, right? 11 plus 4 should be your
15.
K.
Okay.
That is.
Okay. So 15. All right.
You get it? Too easy. When you found this, make a list, but not with zeros. You can say for add number of zeros. You can say zeros. You can say Z1. Do Z1 between 1 and 10. I don't think you can do more anyway. You can say 7, 8, whatever, 7 or 8.
It's smoother than our
Yeah, but you can't get easily caught. That's the main reason you get this.
Okay.
Okay, but to check to see how it returns, and then we will see about how they behave, and then we can say when you get the code, list 10 like that,
It's okay.
10, 20, whatever. Just allow computer to work for you, and then if whatever you get, give it to me. Not all of them work because remember that we have to have the necessary condition to find B low. That means delta minus L should be greater than span CL. If otherwise, that code is rejected.
Yeah. Okay.
You know, but you will find. You will find. It's possible. You will find. So you can say couple of them. But when you get those codes, whenever you get, give it to me. Like I can check for you to find BHN.
Okay.
And then see how it goes. For this one, follow your own, make a list. Should be okay. People should be survived, yes? Sina should be survived.
Thanks for your help, Sina. This was too tight. Thanks for your help. Really, thank you very much.
No, I mean...
Because you put in extra, much of your time, much of your...
That's okay, that's okay. I want to see Kimo is graduated, right?
I want to graduate and
Did you
talk
say
to them.
about the movie it showed on Channel 9?
Movie? I
Yeah.
don't have time to watch in 5 minutes
Interesting.
movie.
I said about, you can...
You know, in